Deep inside these facilities, robotic arms maintain continuous operation in near total darkness. These systems define the current industrial output of the Chinese manufacturing sector. When the world's primary production hub removes human labor from the assembly line, the global economic landscape shifts. Foreign markets still view China through the lens of cheap human labor. They are looking at a system that no longer exists. 20 years ago, Chinese dominance was built on scenes like this: dense, low-cost labor housing for millions of factory workers. This chart shows how that model collapsed. Since 2005, manufacturing labor costs have climbed on a steep, aggressive trajectory. The assumption in the West was that rising costs would drive manufacturing to leave China entirely in search of cheaper territory. But instead, these former factory zones evolved into massive, hyper-modern megacities like Shenzhen. China survived the end of cheap labor by replacing the worker with a massive integration of speed, scale, and robotics. This is a dark factory. Human floor workers have vanished, replaced by autonomous vehicles that navigate the facility without intervention. Manual assembly methods, once the standard for the industry, are being phased out. The Zeekr factory utilizes this automation to scale electric vehicle production on a 24/7 schedule. Western pioneers like Tesla spent over a decade reaching high-volume capacity. The new automated model achieves similar scale in a fraction of that time. A robotic workforce does not sleep. They never go on strike and never negotiate for higher wages. If the peak of manufacturing no longer requires a workforce, the stability of labor-dependent economies is suddenly in question. The factory itself is only the visible output of a much larger hidden architecture. The secret lies in industrial clusters, entire cities engineered to specialize in one specific industry. In Yiwu, thousands of vendors supply wholesale components in a single location, while cities like Dongguan focus exclusively on fashion manufacturing. This specialization is fed by raw industrial infrastructure designed to process materials at massive scale. A synchronized logistics network physically connects these cluster cities, forming an unbroken supply chain. That chain leads directly to ocean terminals, where thousands of containers are prepared for global export. No other country possesses this density. The true competitive moat is the geographic proximity of the entire supply chain. This density creates an iteration speed that Western competitors cannot match. While hardware prototypes in the West can take months of coordination, teams in Shenzhen complete cycles in days. Every engineer, supplier, and component manufacturer is located within a few city blocks of each other. This environment operates on a simple rule: information travels at walking speed. This is ecosystem intelligence, a biological-like machine optimized for rapid evolution. The system is now a self-sustaining loop, iterating and producing at a scale independent of human rest. This industrial giant is already awake. The world must stop asking when it will catch up to this automated ecosystem. The real question now is whether the rest of the world retains the capacity to compete at all. While competing nations were focused on the cost of human hands, China was building an autonomous industrial machine. The strategy behind this transition is a state-engineered directive known as Made in China 2025, championed by President Xi Jinping. The plan aims to eliminate reliance on United States technology and achieve domestic self-reliance across all advanced manufacturing sectors. To hit these targets, the state directs capital into dedicated infrastructure and aggressive subsidies specifically for robotization. In 2023, for every 2 new robots deployed globally, 1 was installed in China. Tracking this over 5 years reveals a clear divergence. Western adoption has plateaued, while Chinese capacity continues to rapidly climb. This concentration of hardware is more than economic growth. It is the active deployment of tools for a 21st century industrial war. The primary battleground for this automated arsenal is the global electric vehicle sector. This visualization highlights total EV production volume, showing that Chinese factories now produce more electric vehicles than the rest of the planet combined. This volume is forcing legacy automakers like Ford, GM, and major European brands into a defensive posture. These established companies are managing high labor costs, union negotiations, and the slow rollout of charging infrastructure. In contrast, these new manufacturing hubs utilize deep state subsidies and an automated supply chain that operates with minimal overhead. If this output continues to expand, global electric vehicle prices could drop to levels that make Western competition impossible. Governments are now treating this as an existential threat to their domestic industries, escalating the response to a geopolitical level. The United States has responded with aggressive tariff hikes, while the European Union has launched investigations into the scale of Chinese state subsidies. This economic friction is no longer confined to rival superpowers. It has reached developing markets. Emerging economies in Brazil, Southeast Asia, and Africa are watching cheap imports undercut their own domestic manufacturing sectors. The physical weight of this strategy is visible at global ports, where massive cargo fleets are delivering a constant stream of finished goods. This raises a question. Can traditional political tools like tariffs stop an industrial machine that removes the variable of human labor costs from the equation? Extreme automation carries an internal paradox. Peak efficiency creates a volume of goods that can quickly outpace demand. Chinese assembly lines are currently building vehicles faster than global consumers can purchase them. Rapid factory expansion and a crowded market of EV startups have triggered aggressive price wars within China's own borders. The system requires constant motion. These highly capitalized facilities cannot be powered down without causing severe economic damage to the state. The greatest threat to this automated empire is the possibility that the global market simply stops buying. Similar automated facilities are beginning to appear in high-cost labor markets globally, following the technical logic established in these Chinese hubs. This visual highlights the contrast. The precision of the automated line makes the human element appear slow and inconsistent by comparison. As artificial intelligence and advanced robotics continue to merge, the economic purpose of human labor on the factory floor is being phased out. China achieved its dominance by scaling this frictionless system, while global competitors remained focused on the cost of a human worker. This shift is no longer about which country wins the trade war. It is about whether humanity will retain a place in the manufacturing systems of the future.